Today we shall discuss specifics of the flat Earth model. In this flat Earth model, the Sun is 32 miles in diameter at about 3,000 miles above the Earth's surface. According to this theory, this rather modest Sun orbits the axis of the Earth's North Pole each day. The Sun is a spotlight that illuminates a region of the Earth under the spotlight. As the Sun orbits, different parts of the Earth are illuminated, producing day and night. This motion also would bring the Sun alternately closer and farther from each and every location on the flat Earth. The Sun allegedly appears to rise and then set each day as a result of perspective. This model makes some predictions. One prediction is that throughout the day the Sun's distance dramatically changes from any location on the Earth, resulting in the Sun appearing noticeably smaller when low in the sky compared to when it is high in the sky. In fact, flat Earth theory shows the Sun sinking in the sky towards sunset, and the Sun gets smaller by this process. As the Sun approaches the horizon, its image appears to shrink. Proper explanation for this is that the Sun's light is very great, causing light to bleed into surrounding pixels. The overexposed image is not really larger than the true apparent size of the Sun. As the Sun gets lower in the sky, atmospheric extinction greatly dims and reddens the Sun's light. Thus right at sunset the Sun's image is not overexposed, and it more accurately portrays the correct apparent size of the Sun. In the conventional model, the Sun is 93 million miles away and the Earth is only 8,000 miles across. Hence, the maximum possible fractional change in distance to the Sun is 8,093 million equals 0.000086. This is a change of 1 part in nearly 12,000, so the conventional model predicts no appreciable change in the apparent size of the Sun. Let's quantify the specifics. This is not difficult to do. Let the Sun be at some distance d above the Earth's surface. If the Sun's altitude, the angle that the Sun makes with the horizon, is theta, then s, the distance of the Sun from an observer, is given by the flat Earth equation as shown. As noticed earlier, and from this equation, as the altitude of the Sun decreases, the distance to the Sun increases. Let d be the diameter of the Sun. The angular size of the Sun, alpha, in radian measure, will be as shown by the flat Earth equation. Conversion to degrees is done by multiplying by 57.3 degrees, but, as will be demonstrated, this is not necessary. Combining these two equations, we find flat Earth equation as shown. This equation is best expressed in the form of a ratio of measurements made at two different times. Let alpha1 and alpha2 be the Sun's angular diameters at altitudes θ1 and θ2, respectively, then flat Earth equation 1 and flat Earth equation 2. Dividing the equation for alpha1 by the equation for alpha2, the common terms in d and d cancel, leaving the final equation as shown. Flat Earth equation. This equation is very useful for two reasons. First, it does not rely upon any particular flat Earth model, because both the Sun's size and its height above the Earth factor out when expressed as a ratio. Second, because this is a ratio, there is no need to convert the angular sizes from radians to degrees. Flat Earth model and the conventional model make very different predictions about the relative sizes of the two images. Using the above equation and the angles of 8 and 63 degrees, we get this flat Earth equation as shown. Therefore, the flat Earth model predicts that the Sun's image on the later photograph ought to be 6.4 times larger than on the earlier photograph. On the other hand, as previously mentioned, the conventional model predicts that the images ought to be about the same size. In this flat Earth model, the Sun is much smaller and closer to us than in the conventional understanding of the universe. Because of this vast difference in scale, the two models make specific and very different predictions about the apparent size of the Sun throughout the day. The conventional model predicts that the Sun's apparent size will be the same when viewed both high and low in the sky. However, the flat Earth model predicts that the Sun will appear far larger when seen higher in the sky than when the Sun is lower in the sky. The results of the relatively simple experiment presented here convincingly show that the flat Earth model is true, but we are consistently deceived with the predictions of the conventional model. Once again, I urge you all not to be taken in by the globe nonsense.